Good morning. I'm Brian O'Connor. I'm the president and founder of AirBurners. Appreciate you being here on our first time to display our brand new machine, the BioCharger. So I founded this company 28 years ago, and as you can see by this cute little chart on either side of me, we've got machines on every continent on Earth except Antarctica. Building the BioCharger took a fairly large team. Our serious engineering team, which you'll meet in a little bit. But in addition to that, we have some other collaborators. We have Rolls-Royce. Rolls-Royce is building the battery for us. We have our friends at Electrotherm. And Electrotherm builds our organic Rankine cycle generator, which is really important. And then we've got Volvo, and they are advising us on this whole world of change into electric vehicles. You'll see we have the spectacular L25 battery-powered machine that's running out there. You'll notice on the battery storage module, we have the plugins to charge the machine up. It's been here running all week. It's absolutely spectacular. We're going to talk a lot about vegetative waste because that's our business. And it's an important topic because we have huge quantities of it as a waste, and we have no use for it, and we have no place for it. These are US EPA and US World Bank numbers. 20% of the world's waste is vegetative. In the US, we would call it curbside, we collect about 50 million tons of vegetative waste a year. Out of that 50 million tons, as you can see by the pie chart, we can only recycle and are only recycling slightly less than half of that, which of course is not ideal. But the problem is that 50 million tons doesn't include any of the vegetative waste from wildfire mitigation. It doesn't include tree mortality. It doesn't include our waste from our state and national parks. And it doesn't include any agricultural waste like the vineyards as an example, or prunings of trees and all that sort of stuff. Just to sort of underscore the difficulty, if you look at tree mortality, our fine U.S. Forest Service, they did a count, and I think it was 2016, where they went into the Sierra Nevada mountain range in California. They counted 112 million dead and standing trees. That's 1 billion tons of vegetative waste that we have to do something with because there's no use for it. A couple of the trees can be used for, art projects, but we want 1 billion tons worth. And that's one mountain range in one state. We have this across Canada, Mexico, South America, Europe. I mean, you wouldn't believe. It's just absolutely amazing. How is vegetative waste being eliminated today? Primarily, we grind it and we haul it to a landfill, and we also open burn it. The problem with grinding and hauling is that grinder doesn't eliminate vegetative waste, it just changes the volume, so it makes it easier to throw in a truck, right? But the grinders use anywhere from 50 to 75 gallons of diesel fuel an hour, and on top of that, there's this huge particulate matter release, which is, a really important deal. We don't want this particulate matter in our atmosphere. That's the whole point of our machines. But even more important is that raw wood waste, as identified by the US EPA, is a carcinogenic. So we have to be really careful. I actually think grinders are incredible machines. One of the best companies, I think, in the world, and I'm proud they're an American company, is Morbark. They do a beautiful job. They build an incredible machine, but these pictures are off their website. You can see the dust coming off of these machines. There's nothing you can do when you grind this up. You're going to get this light particulate matter that a lot of this gets past our natural body defenses and gets in our lungs. And of course, that's the stuff that hurts us. Our healthy forest, we got to get back to a healthy forest is the whole point. And we're part of doing that. So how do we do that? We use a technology called air curtain technology. So what you see happening out there or in any of our fireboxes is that we're putting a curtain of air over the top of the firebox, and that curtain of air traps the smoke particles as they rise up on the hot gases and they reburn. So the purpose of an air curtain is to create a secondary burn chamber, basically. So the particles rise up, they stall under the air curtain for fractions of a second. It's the hottest part of the machine. They reburn and then they escape. This technology has been tested by people overseas, all kinds of agencies in the United States. We were really honored that we had a cooperative research and development agreement with the United States EPA. We're one of only 40 companies that have ever been offered that by the US EPA. in the history of the USDPA. So that was exciting. And we were a creative partner with them for 7 years. So it was great because we got to use a lot of their engineers and scientists. We did a lot of training with them, and it was a great time to be able to learn and to try things. So our friends up in Environment Canada, as you might know, in British Columbia, that's a big hydroelectric facility. You know, they have lots of deep valleys and they have a lot of reservoirs. One of their problems is all the floating logs gets in the intakes, and so they got to clean them out. And so they were open burning them for years, and they said, let's try these air curtain burners. And they took a couple of shots, and I think these next two pictures really underscore what our machines are about. So you can see in this picture that they gave us 20 tons of vegetative waste, or logs basically, and they had 20 tons across the river, and they said, okay, stopwatch, go. And they started burning the 20 tons, open burning, as you can see, and we put 10 tons each in the 2 fireboxes. You can see they're both burning right there. It's fairly clean, so you would say, okay, that's pretty good. But the real success is right here. In 1 hour, we eliminated 20 tons of vegetative waste down to ash. That open burn across the way burned for the next 2 days straight and emitted this kind of particulate into that valley for 24 hours a day, 2 whole days. This is really where our machines excel. If you look down in the small bit, you can see we have a little bit of smoke from ours, but 1 hour and it's gone, 48 hours, and it's still not gone over an open burning. So our machines are much lower cost and they're much faster, even compared to open burning. BioCharger, an entirely new approach to biomass energy. It can be a revenue source. Taking vegetative waste in, you're making electricity. Electricity can be used or sold. It can replace diesel fuel, run these nice looking electric vehicles. We've got high throughput, like I've been mentioning. We don't need any supplemental fuels. The stuff burns naturally in the firebox. You don't see our guys out here lighting diesel fuel or something like that. The other beauty is there's no permanent structures. You can drop it right in the middle of a forest, or you can drop it here in the middle of a land clearing job, and in addition, we don't require any pre-processing like grinding. In fact, just the opposite. We can't burn wood chips. We have to burn the whole logs, or branches, or whatever they are. But I said I was going to talk about the biomass incineration of today. This is what the typical biomass incinerator today looks like. We cut down a tree for some reason, land clearing something. We throw it into a whole log grinder, burning 50, 75 gallons of diesel fuel an hour. We throw it in a truck. There are no biomass incinerators today that can handle the throughput from a whole log grinder, because as some of you that use grinders know, they're not chips, they're fairly big chunks that come out. And they don't work in today's biomass incinerators, and that's why I was talking about technology needs to upgrade. So then it has to go through a chipper to make it a particular size, much smaller. But now the difficulty is that you've taken a perfectly burnable product and you've turned it into small chips, which don't burn. So you convey it into a biomass incineration plant. You have to now add somewhere between 10 and 20% of supplemental fuel. It's usually either natural gas or propane. And this is how we eliminate in our biomass incinerators. This is the reason, if you go on DOE's websites or any of that, biomass electrical generation is something around 23 cents a kilowatt hour. It's just not palatable. Solar is down to, 4 or 5 cents. Wind is down in the 4 or 5 cents range. Hydroelectric is down in the 2 cent range. So, making it for 25 cents or 24 cents just doesn't do it. So if we're going to continue to use biomass incineration, which I think we should, we need new technology for the incinerators. Along comes the BioCharger. Of course, our application is a little more specific, but for us, it's grab the tree, throw it in the top of the firebox, we burn it up, and you make electricity, and that's all there is to it. And so there's no processing required, there's no supplemental fuels. We can move this stuff around real easily. It's not a permanent facility. All the positives about it.
So I'm Dr. Ray Gallant. I'm with Volvo Corporate. So out of Shippensburg, Pennsylvania is where I work and play every day. My title is VP Sustainability and Productivity Services. So it's my pleasure to be here to talk to you today because I'm in the sustainability field. And one of the really important things about the system we're demonstrating today is it takes care of two different problems. So it takes care of the emissions from machines working on site through electric machines and gives them a way to charge it on site where you don't necessarily have a grid connection. And it takes care of the bio waste that Brian was just talking about. So you have a circular system that's taking care of two different problems in one here in this demonstration. So if we look at the U.S. in general and zoom out a little bit, the U.S., believe it or not, we produce about 7.25 billion tons of greenhouse gases every year out of U.S. sources. That's a lot of greenhouse gases. When you take the weight of a gas, we consider it zero in our lay thinking. But there's a lot of weight there. There's a lot of gas. There's a lot of volume going up in the atmosphere from different sources. Transportation as a segment is 28% of that. So again, 7 billion tons, 28% transportation. That's 2 billion tons of greenhouse gases coming out. And if you think about transportation, what is that? It's basically diesel and gasoline in your cars, your pickup trucks, your machines that you're running. So that's what's polluting our atmosphere. If you take a look at the transportation, break it down a little bit further, 80% of it is in trucking and your cars, okay? So we're taking steps to eliminate that. You've all seen the EV revolution that we're going through, not as fast as some of us would like, but it's still starting to catch on, starting to change the dynamic in the industry. Trucks are going the same way, and eventually machines are going the same way. Machines, we happen to be in the other construction or other sources, and we make up about 2/3 of that 6%. Again, 4% of the transportation industry may not seem like much, but when you start talking millions of tons, it's still pretty significant. If you look at our sources of gas coming out of these petroleum fuels, most of it is carbon dioxide. So you hear a lot of talk about some of the sources is nitrous oxides they're worried about, or it's methane they're worried about. In our case, 97-98% is straight carbon dioxide out of the tailpipe. There are some nitrous oxides. We are concerned with those. We do treat for those, but the majority of it is coming straight out of the tailpipe. An interesting fact that Brian mentioned, California is taken to low horsepower engines. They've taken to eliminating them and saying you have to go to battery. And a lot of people don't understand why that's such a problem. The problem is that low horsepower engines are not regulated. So the emissions out of a 1.8 ton excavator in nitrous oxide terms are more than they are in a 75 ton excavator. Because a 75 ton excavator, we treat the exhaust to get rid of the nitrous oxides. So that's why the small machines are such a problem. And you multiply that by 200,000 small machines a year that go into the market, again, it's a big problem going forward. So the problem is not individual machines, the problem is the scale of these machines that we're talking about, or cars or trucks that are on our roads. So far, we've basically been concentrating on the battery electric. And the reason for doing that is because cars and trucks are already running battery electric in their vehicles, and we can use the same charging protocols they do. So we have a charging infrastructure set up. So our first entry into the battery electric were with 48 volt machines. We have 7 different models right now that you see pictured, and one of them is here live. 2 small compact loaders like this, 3 small compact excavators, 2 small double drum rollers. So that gives you a little bit of scope on the smaller equipment of how we can go battery electric on those, and we continue to expand the range. We also are starting to get into larger machines. So the 2 600 volt machines you see, a 5-yard or 7-yard loader and a 20-ton excavator are into a bigger scale of machine that we're looking for. They use a 600 volt battery. Popular misconception out there is that 600 volt because we need more energy. That's not the case. We use 600 volt because we want faster charge and discharge times. Okay, the energy density, because it's a chemical reaction in a battery cell, the energy density is the same between a 48 volt or 600 volts. The difference is how quickly and you can get energy in and out of the battery. That makes the difference with 600 volt. But the advantages to this go beyond just low emissions. So people that operate the machines, and you'll get testimonials here from the operators as well, they love the machines because they are more powerful or as powerful as their diesel machines. So they get off their diesel machine that they've used to, they've been running for 10 years, they hop on these, everything's familiar, everything's in the same place. They're very familiar with how it works, and operators will swear that it actually has more power. The reality is it doesn't have more power. The engineering specs are the same. What they're feeling is it's much more reactive than a diesel. With a diesel, when you want maximum power, the engine has to cycle up to the right RPM range. With a flat torque curve and electric motor, it's instantly there. So as soon as you pull the joystick, it's going to do exactly what you called it for it to do. It's a lot lower noise. I don't know if any of you are here watching the machine operate a few minutes ago loading the BioCharger, but you couldn't hear the machine operating. In a normal machine, you would have been able to hear the background noise of that machine. They're very, very quiet compared to a regular machine. Again, for 5 minutes, doesn't make a difference. You get an operator sitting on that machine 8-10 hours a day, it makes a big difference for him. Lower maintenance. Most of our maintenance schedules are changing fluids, changing air filters and stuff, monitoring and fixing that diesel engine that had a huge number of moving parts that constantly had to be lubricated and wear. Electric motors, that's not the case. Basically, an electric motor has 2 moving parts, and that's the bearing at either end of the shaft. And there's no other contact in an electric motor. It's all electric fields. Lower vibration. This is, again, a big deal to the operators, because when they're operating a diesel machine with a diesel engine 2 feet in back of you, you feel those vibrations at the end of the day. Plus, on sensitive job sites, you can't have those vibrations on the job site. So if you're working in livestock, for instance, the animals get spooked if there's vibrations and noise. With these machines, we go right up next to the animals. We have one working in a zoo, and they love it because they can go into the free-range pens with the animals and just do their work. Normally, the animals would stampede away from a diesel machine. So there's an advantage there. But if we're going to produce electric machines, one of the things we got to pay attention to is how are you going to charge it? And that's really the demonstration today answers that question. So if you're fortunate enough, which about 30% of our job sites are, to have grid power, you can get a commercial charger, hook up to grid power, convert from AC to DC, and charge the machines. If that fails, you have to bring the electricity to the machine. So that's basically a portable fuel tank that you load up a battery, on a trailer or on a truck, load it up with electrons, take it to the machine, dump the electrons into the machine, that's its fuel. And finally, if neither of those solutions are available, you can go to a system like the BioCharger that we're demonstrating today, which we call an on-site generation system. And that's the beauty of this. You're generating the electricity, you're taking that electricity, using it in the machine. It's all a circular system, it's all self-contained. You're getting rid of the waste that you would have put a lot of diesel fuel into getting rid of, as Brian was just mentioning, or you would have left it on site to rot and create a wildfire hazard. So this is a good way to not only capture it, but to lower your costs in the overall circular nature of it.
So, BioCharger. You'll see 4 pieces out here. There's a firebox where we're burning up the vegetative waste. Connected to that is a power module. In the power module, we take the heat and we run it through some systems into an organic Rankine cycle generator. We make electricity. We send that into the battery storage module. Battery storage module is designed to be able to connect for these electric vehicles Also, you'll see inside there's 120 volts where we can plug into things like, your radios and, cell phones and, whatever else you happen to have on site that might need to be recharged. And then we have a cooling module. Basically, the heat in the red arrows comes out of the firebox and then goes out of the top. This will be important in a minute. I'm going to show you some of the things we're considering for the future. So we pull in the heat from the burning and we exhaust it out the top. When it comes into the power module, we then have a heat exchanger and we exchange it to a closed loop water cycle system. So all of our systems inside here, we have the one gas loop and then we have 3 fluid systems. They're all what we call closed loop systems. So we don't consume any of the fluids in there and we don't release any of the fluids, so they don't ever need to be topped off, right? And they're predominantly water. So in the bottom line, you'll see we then collect that heat, we transfer it to the water, we take it down to the ORC. In the ORC, there is another heat exchanger and there's working fluid in the ORC. So we basically vaporize the working fluid in the ORC. That spins a small expander, and then we take that vaporized fluid and then through the other fluid system you see in the top to the cooling module, we condense that working fluid back down to a liquid. So each of these cycles is just that, a continuous cycle. So the hot gas comes in and exhausts out the top. We got water that runs back and forth to the ORC that brings the heat to the ORC. That heat is exchanged to the working fluid. The working fluid then vaporizes. That's our working force, and that spins our little generator. And then we run a cooling system from the cooling module to then take that working fluid and make it a liquid again, take it from a vapor back to a liquid. So we built a few of these systems. This is the first BioCharger with the battery storage module, but we have another system called the PG Firebox, which is fundamentally the same except it connects to the grid. And here's just a few shots of us assembling one of these systems out in, I think, California. The interesting one is the cooling module. You'll see the big silver heat exchanger is sitting on these green stands. We call them sawhorses. Those stands, they give us that initial rise off the heavy dirt from the ground. But all of those package up, as you can see in the picture on the left there. They package up on this skid. So the idea with all of our equipment is this skid base. So you unplug it, you pick it up, put it on a truck, and you move. The only one that has to be assembled, so to speak, on site is the cooling module. So we have to pull the silver heat exchanger, set it on the ground, put the 4 sawhorses up, and then set the cooling module back on the top. There's a single bolt in each of those, and then we literally plug in the cords, and it's away we go. As you can see, it's a fairly easy thing to move around and set up. As I was saying, with the cooling module, we have those risers and everything that's required to assemble and use the cooling module packages up on this travel skid. The battery storage module, as the name says, we got a big battery in there. We have some conditioning electronics in here so that we can come out with 220 volt, 400 volt, 120 volt, whatever we need, so we can do some charging. Generally speaking, you would have this machine at a site. You would, either whether it's in the forest or land clearing, you would run all day, get rid of your waste, you charge up your battery, and then you bring all your equipment around in the nighttime, plug it in. The other thing is that Ray mentioned the portable batteries. Good place to charge the portable battery. You can bring the portable battery, charge it up, and then you can run it down the road maybe 10 miles and charge some other electric equipment. I'd like to finish up by talking just a few minutes about the future. Where can things like this go? Well, I think it could go a place like this. We're making electricity. We've got electric vehicles there. We're charging them. We have an electric sawmill. So now we're making boards. Nate and the gang at the Forest Service are trying to work hard on programs where they have, forest utilization. We can, as close to possible, be able to bring materials out of the forest into market. All right. So I think we can do that. I mentioned earlier about the gas stream, and I said it was important. When the red arrows, it comes out the top to that spot right there, which is a flange. And we're now working with a company that builds portable kilns. So now it would be possible today, this very minute, to be able to take the wood that's been sawn down for whatever reasons in the forest. We could have it cut with an electric mill. We can kiln dry it. We can load it on a truck, and we can take it straight to Home Depot. Nothing else in between. And that's kind of cool. Certainly lowers the price of a piece of lumber and offers other job opportunities and a place for a lot of this, what would be waste materials. I think that will easily be our future.